Alright, so this video is just to talk about some of the volcanic hazards and some of the eruptions that have happened over the history of Earth. So, in the last 10,000 years, over 1,300 volcanoes have erupted. So we have volcanoes that are classified as active, which means they'll still erupt, and then those classified as dormant, so they haven't erupted in a really long time, but you never know. And then you have extinct, which means they are not going to erupt again. So this is the map that you guys are going to be plotting your little volcanoes on. As you can see, it kind of lines up with the plate boundaries you already drew. That's just the next part of your project. You'll find that 60% are around the Pacific Ocean. So you see some volcanoes in Washington, Oregon, California along the coast there, and then down the South American coast, and then all the way around that Pacific plate, and that is called the Ring of Fire because of all the volcanoes that are located in that region. Then you have the Mediterranean region, and that's going to be over there by Africa. You have a couple volcanoes over there. Notice that Iceland has a lot of red dots on it, so it is a very volcanic. Alright, major volcanic eruptions since 1600 AD. Well, you have Nevada del Ruiz in 1985 in Colombia. And what was dangerous about that was the lahars, and we'll talk a little bit more about what that is in the next few slides. And then you had the pyroclastic flows, and Japan was a cone collapse and a tsunami. And then, of course, there's also starvation, all things that we will talk about. So, death from volcanic hazards, 1586 to 2000. So, your big coffins represent over 200,000 deaths. Notice the big coffin is in the Japan area, whereas there's smaller ones in Africa, and a slightly smaller one even in Iceland, which has a lot of volcanic activity. You'll notice there are some mid-sized little coffins there in South America, and in the United States we haven't even gone to 1,000 deaths, which that's pretty good considering the volcanoes that we have. So how these volcanoes erupt depends on a bunch of different things, including tectonic setting. Are they at a divergent plate, convergent plate, stuff like that. The depth of the magma formation, if the magma is deeper inside the earth or closer to the surface. And you also have the rate of magma movement to the surface, so how fast that magma from whatever depth it's at gets to the surface. And then you also have different amounts of gas in different volcanoes, and there are actually people who go around and sample that. And the gases change before an explosion, or before an eruption, so you can kind of monitor that to somewhat predict a volcanic eruption. So here is the picture of tectonic setting. So you have that subduction zone, you have a hot spot like Yellowstone, and you have ocean ridges, and all of these are going to produce volcanoes of different sizes. So your oceanic ridge and hot spots are mafic volcanoes, so they don't have a lot of silicon dioxide, which is that SiO2 that you see on the screen. and notice that this lava moves very fast, 10 meters per second, so it's very fluid. And it's not really an explosive type of volcano, it's more of the lava is just leaking out into the surface. So it's not going to blow like, say, Mount St. Helens, like that did in 1980. Subduction zone volcanoes, which are like the Mount St. Helens, Mount Rainier, Mount Shasta, are felsic volcanoes, so they have lots of silicon dioxide, and they have slow moving lava, so 3 meters per second. And the word that they use to describe it is viscous, and viscous is used to describe, how well a fluid flows. So like your corn syrup is going to be viscous, whereas water is not viscous. So that's what that word means. And these are going to be fairly explosive volcanoes like Mount St. Helens. So your volcanic hazards in the past 100 years, a lot of them have been pyroclastic flows, which are just hot material that's so hot it just burns everything. It's responsible for quite a few deaths because it's really difficult to outrun because it's so fast moving. You have your lahars, which are your mud flows, and those hot mud flows tend to take out quite a few people. Disease as a result of the explosion, respiratory disease is a hazard. Tephra falls, that's chunks of rock falling from the sky that were shot out during the volcano's explosion. And then, of course, you have others and unknown. So here is some basaltic lava flow. So you see this lava approaching a stop sign. It's kind of blocky, and they call it lava. Then you have ho-ho, or as my Haitian kid said, hooey. And that is Europe lava, and you can kind of see it in that picture there. And lots of property is burned and buried by this. So the most famous historic eruption was probably Mount Vesuvius, which destroyed Pompeii in AD 79. It's had eruptions since then, but this one is incredibly popular because it killed Pompeii, or the people of Pompeii, in their sleep. And you can visit the ruins of the city and actually see the remains still in their little sleep positions. It killed them instantly. So, and there's a lot of artifacts that are preserved in the ruins of. So here's a picture of what the modern day area looks like. And it says here that the city Herculaneum is actually below the surface of the modern city. So, one of the biggest hazards that happen in volcanoes that explode in our area is going to be our volcanic ash. And it causes lots of health problems. And it messes up ventilation systems because you get lots of ash in there. They don't work very well. They're not letting air through. Damages crops. If you get any ash in a plane engine, there goes the plane. If you fly a plane through an ash cloud, it's gonna go down. Volcanic mud flows. And basically, it's just a bunch of hot mud that's caused by the melting of the snow at the summit. So if you look at most volcanoes, their tops are covered with snow. And obviously the eruption, you have really hot magma, so it's going to melt and it's going to create lahars, or mud flows. So you would have the eruption, it melts all the stuff, the steam goes up, it condenses, it falls, and then you have a volcanic mud flow. For example, the lahars of Mount Rainier. So you can actually see Mount Rainier and where all of the mud flowed. Granted, that explosion was a while ago, but you can still see evidence of the mud flows caused by that explosion. So basically, what volcanologists will do is they are studying volcanoes and they look for high risk ones. So high risk ones are ones that erupt often, and they show signs where, like, when you go and you study nature, you see disruptive um, patterns or population density and property value in the vicinity of a volcano. For example, Vesuvius, there's a huge town there. If that thing explodes again, it's going to wipe out a large portion of the population. So that would be a high risk volcano. It's going to destroy a lot of property. So they're monitoring the gas emissions, what type of gas is coming out of the volcano. They measure geophysical movements, ground deformation, so some depression that used to exist that's since risen, stuff like that. They also look at seismicity, which is something you normally associate with earthquakes, but earthquakes do happen around volcanoes, and they also use remote sensing, which is satellites, which we talked a little bit about earlier this year. And here is a picture of someone actually taking a gas sample at a volcanic vent. So then you have what we call supervolcanoes, and we live really close to one, which is why we're addressing it. So supervolcanoes are giant continental calderas. So if you look like Yellowstone National Park is like in a huge caldera of a volcano, is essentially what it is. So that's why it's called a supervolcano. It's very large. And if it were to explode, it would cause a massive amount of damage. Okay. So the last supervolcano eruption happened in Long Valley, California. So you have a huge distribution of ash beds. You can see it goes all the way up into Wyoming, considering where the volcano erupted. And here's an example of some geologic cause. So here you have the ruins of a Roman market, and as you can see, in 1976 it was covered in water, and then by 1984 it had been lifted up so that there is no water. It's not covered in water anymore. And that was because of the volcanic forces in that caldera.